Welcome. I'll just give a quick rundown of the meeting and we'll go ahead and get started. So today Keane will be giving a talk on organic vulnerability discovery. Afterwards, depending on how much time we do or don't have, we may try to play some Artemis, but we haven't really worked out the logistics, so we'll see how that goes. If we don't have time, then we'll just go straight into the info session for the National Cyber Analyst Challenge. So if you haven't heard about that or are interested in hearing about it, make sure you stick around for that. So we'll pretty much be rolling into that after the talk or after we play some Artemis. But we're going to be starting that at 6:15 at the very latest. So going off of that, I'll be sending out just a short Google Forms survey through Slack based on you guys can give feedback on how you thought the cabinet did and IASG did this semester. If you want to see anything for next semester, make sure you submit there. There's some fields that let you do that. And if you have any interest in presenting or anything like that, make sure you include your interest for that as we'll be planning for next semester, probably next week. So without further ado, we'll have Keane. Go ahead.
All right, so I'm Keane O'Kelly, and I'm giving a talk today about organic vulnerability discovery. And so during this talk, as usual, if you have questions at all, please feel free to interrupt me and ask that question or clarification, anything like that. There's also pizza in the back. Feel free to get up and get that anytime during the talk. And I also did bring candy that I can hand out if you answer questions, which I almost forgot about. Thanks to the candy cane up there, I was reminded. But anyway, let's get started here. All right, so first of all, there's a common misconception. I hear these terms thrown around a lot, vulnerabilities and exploits, and they're often mixed up. So I'm going to clarify what they are, first of all, before we get started here. So what is a vulnerability? A vulnerability is typically something that is, well, an error or an issue with a system that eventually allows it to be exploited, but it's going to be a bug or flaw in a system that may or may not be exploitable. So it could be something as simple as misconfiguring your application, messing up the config file. Could even be something like user training, not training your users to not plug in flash drives they find on the ground, or even leaving a door open. Those are all vulnerabilities, things that an attacker or a threat could come and exploit to take advantage of. Then we have exploits, which are a means to use this vulnerability to gain access. So maybe you get remote code execution, maybe you can view information you're not supposed to have access to, or maybe you can modify information. And a lot of it goes back to this CIA triangle you see a lot in InfoSec, where you have availability, integrity, and confidentiality. Exploiting a vulnerability often allows you to compromise one or more of those corners of the triangle. So for example, integrity, if you're able to inject SQL in a web application, you can maybe modify some user data or permissions or something like that. That's violating that part of the triangle. So that's the difference between vulnerabilities and exploits. You'll often hear terms like threat. So that's kind of the person or the group who's planning on attacking you. And there's also risk. You'll hear a lot, especially in business situations where, what are the impacts of someone actually exploiting this vulnerability? What's going to happen to the company? What kind of damage? What's the cost of that? That's called risk. So just some base terms here to iron out before we get started with everything. So a lot of times if you're working for a company or organization, you'll do penetration tests. And a lot of times you'll start with some tools that are automated like Nessus or Nikto, Nmap, just to name a few. Metasploit has a scanner and some other stuff in there. It's really all pretty simple. You enter the target ranges, you press scan, and you get a magical list of all the vulnerabilities in your network. And often with Metasploit, you can press another button to go ahead and exploit all of those. Now, that's not very exciting. These tools are doing a lot of the work for you. And we get a nice list of vulnerabilities. Can anyone tell me what is in common with all these vulnerabilities that we might find in a scan? What do these all have in common? Not these in particular, but in any scan, what do the vulnerabilities all have in common? Anyone have any ideas? If you're running an automated tool, what are all the things it finds going to have in common?
They're known vulnerabilities.
They're known vulnerabilities. I heard a few people say it. Not sure who to throw the candy to. Logan gets candy. Who else said something? You said something?
I raised my hand.
All right, you get a candy. They're hard to throw, by the way. But anyway, so you're right. They're all known vulnerabilities. It's not something that you were able to find on your own. It's something somebody else has found before you. and they've figured out how to identify it, how to fingerprint it, and they've written a signature or some other way to do this automatically. So we're simply running an automated tool to look against this known list of things and see if we find known vulnerabilities, which is not too exciting. Now, it's still useful to know how to use these tools. They're pretty useful for finding well-known vulnerabilities and establishing a baseline to make sure you've patched all your systems, you've fixed those annoying bugs that are really killer, but you should have fixed anyway by now. But beyond that, it's kind of a script kiddie thing in some cases. You're really just pressing a button and it's doing all the work for you, giving you a list of all the attacks you can do. So not always a bad thing, but has its uses in business. So the real fun often lies in what I'm calling here organic vulnerability discovery, finding these vulnerabilities yourself, doing it the hard way. So what kind of vulnerabilities are found? There's different categories of vulnerabilities, and usually when you find one, it's not going to be some brand new category of something that's never been seen before. It's typically going to be some category that already exists. So you might have, you've got things like memory corruption vulnerabilities, so that's like buffer overflows, use after freeze, stuff like that. You've got web application vulns, so cross-site scripting, SQL injection, insecure direct object references, and even stuff like social engineering. All the things you might find are going to fit into one or more of these categories. It's not really strictly defined, but there aren't really any new types of vulnerabilities that I can think of at least, so they're all going to fit in one of those. So you'll often hear about different types of discovery that you'll do when you're trying to discover these vulnerabilities organically. The first one is going to be black box, which is, and none of these are to be confused with like black hat, white hat, gray hat. That's kind of a different thing entirely, but also sorry about the colors. The black box is actually white and vice versa, so ignore that. But black box is where you have some product you're testing, and all you can really do is observe the input you provide to it and what output comes out of it. You can't really see what goes on between those points. You're kind of just interacting with this system without knowing. Welcome, William.
Thank you. It's good to be here.
You're interacting with this system without knowing what's going on inside, and you have a very limited view of what's going on. You may have access to the binary and can maybe do some introspection into that using a debugger or something, but often you're pretty limited with what you can do. Really, when I was looking this stuff up just to find a formal definition, I found a lot of sites that were contradicting each other and people having different opinions of where the boundaries actually lied, but as with many models, it's kind of hard to rely on this strictly for defining things like this. So it's really just a model, and keep it at that. Don't think about it too hard. But with gray box, again, kind of a gray area. You have to maybe you're given some of the resources, some of the source code or something, but you don't really have a full picture into what you're dealing with. And then finally, white box, which is the most open type of testing, where you've got complete access into all the source code of your applications. You might have access to the servers that are running the application at real time. You might have access to the databases. You pretty much have access to everything you need to get a full picture of what's going on. And that's really useful for finding vulnerabilities that are spanning multiple services or would be hard to find by just throwing things at the wall and seeing when you get back. That's one of the best ways to fully get an in-depth look at what you're trying to test there. So I found another picture that shows it a kind of different way. If you're doing black box, you're kind of like the user. So that could be, if you're penetration testing a website, you go to the website in your browser and you're just talking to that website. You can't see how the server is processing anything. You just can hit it with your own tools. You don't know what's going on behind the scenes, but you can just observe when you send it this request, what comes back. That's pretty much black box. They go here to say that gray box is when you're a user, but you have access to internals. So you're still kind of sitting here where you're just hitting it remotely, but you might be given some of the source code or something else that gives you a little insight. And lastly, if you're white box, you're like a developer. You can see everything. You can pretty much play with it and watch everything happen in real time just to get a really good idea of what's going on and get a really good picture of it. So any questions so far on anything? All right, so going on here, with both of these, with all three of these types of testing, white, gray, and black box, you can either do automated or manual testing in most cases. And so we'll go on to talk a bit about those and take some in-depth looks at those. So with white box testing, we talked about how it's when you have access to the source code and pretty much everything. Lots of open source projects fall under this because they're open source and you can just go online and find the source code and audit it yourself. So an example of this is the Linux kernel that's open source. And it's huge. It's got maybe 20 million lines of codes nowadays, which is a lot to look through by hand. However, people are still doing it. People just for fun will, not for fun, but for purpose will go through the source code and try to find bugs in order to fix them for usually good purposes, sometimes for nefarious purposes, but usually for good purposes. A lot of it though, since that's going to be too hard to do by hand, is with automated tools. So whenever they push new code to source control, you'll have some automated tools that will run on it and perform some tests. And in this case, since we're doing white box, we can talk about specifically static analysis. So static analysis is a type of automated testing where some program is going to look at the code as written and try to find issues with it, some sort of bug or vulnerability. It's going to look for those things. And they're not just stupid where they have predefined signatures or filters that say, if this line's in the code, it's vulnerable. It's typically pretty smart. It'll look through and find combinations of things that cause vulnerabilities or bugs to occur. And an example of that over here is this code I stole from a website. They have a function here that calls malloc basically. And if you look at it, on the third call, it's going to overwrite I with another malloc, which causes a memory leak. And this is not a serious security issue probably. It's probably just going to result in a memory leak, which is not good for a program. And so what a static analyzer will do, I guess what it doesn't do is it won't just say, okay, this code's fine on its own, because it is fine on its own. The first 2 times it's called, this code does nothing bad. It's totally fine. But if we call it again with the same pointer, and it gets overwritten, that's a problem. And looking at this function, again, it's fine on its own. The static analyzer is smarter than that. It knows that this is being called multiple times because it can see the code, and it'll say, okay, in this certain circumstance, this code is vulnerable right here, or it's bad, or it causes a memory leak. So they're not just dumb tools that will look at the code and make best guesses. They actually kind of follow execution paths and are pretty smart about stuff like that. So some tools are Coverity, which is one of the ones that the Linux kernel uses. So as I mentioned earlier, when they push, a lot of times when projects push to their source control, one of the steps of that will be running it through these code analyzers to find any new bugs to make sure it still complies with the same old standards they had before. A thing to note with this is a lot of these will trigger lots of both false positives and negatives. So false positives in that it'll find issues that might not actually exist or never really happen, or false negatives where it misses things that happen. That's usually the more common case. They don't find all the bugs in programs, obviously, otherwise we'd have no bugs at all. So there's that. Now going into black box discovery. So as I mentioned, you don't have access to the internals of something. You have black box testing. So usually for this, you're given, you might have a binary or something you can't really mess with. And there are some ways to do this manually, but we're going to look at the automated ways here, I guess. So dynamic analysis of this is when you're going to run this program in a sandbox environment. You're going to throw stuff at it into its input, whatever that is, and see what happens to it. You can monitor like the system resource utilization, see if it's leaking memory, see if there's any errors going on like that. We can have this input be randomly generated, which we'll talk about in a second when we go into fuzzing. We can also have predefined input. So if it's a certain protocol we know, we can write tests that try to use this protocol and abuse it. Some examples you might use for developing software are LLVM and Valgrind. Those are tools that you can use as a developer of like a C program to find memory leaks or find why your code's segfaulting. Stuff like that. And similar tools can be used in the build process to also identify those nasty issues you want to knock out before releasing your product. So, great. These tools can be used automatically when you're doing your software building, stuff like that. But, it's more automated stuff, point and click. You set it up once, you forget about it. Only so much fun. So how do we find our own bugs more or less by hand? And we're going to talk about fuzzing here a little bit, but I'm going to have a quick demo here to kind of demonstrate the need for this. Any questions before I do that? All right. So I've got a simple server here I'm going to run. If I can get that over in the right display. Hold on one second here. All right. And I will make this bigger when we pull up code, so don't worry yet about that. Great, it's cut off. There we go. So I've got a simple server here. All it does is listen on a port on my local machine, and when you connect to it and send it data, it'll echo that data back to you. So nothing too complicated there, nothing too fancy, not really a realistic program, but for our purposes here, it's just fine. So as I said, if you connect to it, you can see it got a connection over here. I'm going to write some random text in here, and I get it back. I typed in that first line, I get the second line back. It's pretty simple. So let's say I want to try to attack this program, find a vulnerability or bug in it. What should I do first? Any ideas? What can I get started with here? Any thoughts at all? This program is taking input from the user and presumably doing something with it, saving it to a buffer or something, and then spitting it back out. What might I try to do in order to, trigger some weird behavior? Yes?
Send code.
Send code, possibly.
Special characters?
Use special characters, possibly. What's that?
Overflow the buffer
How can I do that?
by sending a lot of characters.
All right, yes. So that might be a good thing to try. We can also try special characters or code. It depends on the application. Special characters might mess it up if it's like talking to a database or some other protocol. But in this case, this application is much more simple, and we're not doing any of that. You get a candy cane, by the way, William. But I'm not going to throw it. It's not going to reach. Yeah.
Since it's connected to your home computer, it's looping around, right?
More or less, I guess so. Yes.
Would you tell it to send code to another location?
Probably not. This code's really simple. It doesn't do very much, so it'd be hard to get it to do that sort of thing. But William's right. The ultimate goal here is to try to potentially buffer overflow the code and make it do something we want it to do. And the best way to try that is, what'd you say? You said put in lots of text?
Yeah, I was thinking maybe copy, see if you can find a text version of War and Peace.
That's one way to do it. You could sit here and you could mash on the keyboard all day. That's not going to be very effective. That didn't bother it. What we can do is some scripting in order to achieve that. We could put in a whole book. That's one way. Or we can just shoot a bunch of A's at it or something. That's a bit easier. Saves me a bit of time from Googling that book. But I do have a pre-written script here. Crash dots, yeah. So here's a simple Python script that I wrote up earlier. So all we're doing is we're creating a socket object. We're connecting to our server on localhost, and we're sending it basically here 100 A's. We've got A times 100. That'll send it 100 A's. And then we're printing the response up to, is that 99 million or something? I don't know. So we're going to print the response, whatever it is we get back from the server. So if I run this, I will get 100 A's back, so that didn't crash it. We can increase this, let's say 1,000 A's. I still get a response back. The program did not crash. What if I do 10,000 A's? Ooh, I get nothing back. So it looks like the program crashed. That's interesting. Not much I can do with that yet. Anyone know what I'm kind of missing from, how is that not really completely helpful yet? Yeah.
At the end of it, you could append a command, maybe?
Not necessarily. I guess I'm referring to more of the method I was using there to find the amount of A's. I mean, are we good now? Can we hack it, or is there more we need to do before we could do that potentially?
Maybe you need to find the exact point.
Ah, exactly. That's 2 candy canes. All right, so he's right. We're just currently kind of guessing with large increments of A's, and so we found where the buffer was overrun, and the program crashed, but we don't really know where exactly, and we can't do much with that information. Sure, we know it was somewhere between 1,000 and 10,000, but for writing an exploit or even publishing this, you'd want to know more than that. So what we can do is we can write a quick loop to try and increment all the way until we find a point where it crashes. And I'm not going to demonstrate that here because, well, I guess I can. Why not? So we'll connect to it, and we will. So for I in range, we'll start at 1,000 since we know it works there, and then we'll go to 10,000 since we know that crashed it. We'll do, oops, caps lock. And we'll do this times I. Is that going to work? Anyone see any problems with that?
Check your receive size. If response is empty, then...
Oh, yeah, okay. Right, you're right. So the most important part, actually, letting you know when you find the magic number. So we'll assign that if, and how do you know what the length is? Oh, never mind. The length function, yes, exactly. This isn't C, I keep forgetting the difference sometimes. All right, so if the length is 0, then we can, can print I, and then we'll return, or exit. Can't type under pressure. All right, good. So now if I run that again, we get 1193. Now that's actually not what I was expecting. The buffer was actually 1024 bytes, but perhaps there's some offset I don't know about where that makes sense. So I guess that's a good step. So now we know that this program can crash if you give it too much input, and we have an idea maybe where that buffer ends or where we can start to overwrite important things like the instruction pointer or return pointer. We're not going to go into the details of actually exploiting that, but this is kind of an intro to fuzzing, showing how you can start to find these types of vulnerabilities. So that's the way to kind of do it by hand. We wrote a script there to throw input at a program and see what comes back, see if it crashed, and it indeed did. In a lot of cases, this might be all it takes to find out that there is some kind of buffer overflow or some other memory issue in a program. And keep in mind, those types of bugs are not trivial. Like, you can use a buffer overflow to gain complete code execution on the machine and start running your own commands on the machine and take over that way. And so with that, we have, so any questions on what we did there with that fuzzing example? All right. So as we kind of saw there, fuzzing, or as they say, fuzz testing, is an automated way to provide invalid, unexpected, or random data as inputs to a program. And so there we just generated a lot of A's, and that's not expected input at all. It's too much input in those cases, and cause the program to crash. And that's something we could then use to develop an exploit or cause some other kind of trouble. So this can be done automated too, so that was the manual way. It's typically easier to use a well-developed and previously vetted fuzzer, and one of those really popular ones is AFL, which is American Fuzzy Lop. They call it a genetic fuzzer. It's very highly researched, it's very fast, and high gain, whatever that means in this context, but you pretty much point it at your program and tell it how the input's supposed to look, and it'll start fuzzing that, providing random input of different links, different content, whatever it can to try to get it to crash. And over on the right here, you can see it'll keep track of what it's doing, how many times it ran, how many different paths in the program it found. So if if there's different options that trigger different pieces of code, it'll make note of that. Unique crashes. This one here in this example hasn't crashed yet, but it'll, each crash is worth investigating on its own. You might have a lot of the same crash that are, caused by the same or more or less the same thing, but you want to look at the unique crashes, not the total crashes typically. And there's also hangs. Not sure what happened there with their program, but we're gonna try this AFL on our socket application we just looked at a second ago. And actually, I think I should show this too. This program is used on tons of projects, including the Linux kernel and pretty much every application you use. Here's their list, their bragging right list of all the programs and all the vulnerabilities that have been found using it. So it's a pretty big list of big name software. So the pros are using this type of thing to find those hard to find memory related bugs in software. So yes, so if I were to open my code here again, and the thing about it is you can't directly point it at like a network service like I was doing here with my script. It usually runs on standard input. So I have a modified version of this code which is designed for this experiment, and I'll show that to you here. It's like 2 lines. What is all that nonsense? I have no idea what's in my IASG folder. It's kind of questionable. That's a lot of stuff. Anyway, this is all that is. To replicate that program in C without all the socket stuff, that made it a bit longer, but to do what I was doing there is just this. We're reading in some data and saving it to a buffer and then printing it out. That's all we're doing. And here the buffer is much shorter. Before it was 1,000 something, now it's just 4, just to make it a bit quicker when we run AFL. So you actually compile your program with AFL's GCC. And I didn't really research why, but I'm assuming it builds in extra debugging information. So we're going to run AFL on this, and I've already run it a couple times on this, but I'll do it again. AFL, so we run AFL analyze, and it's going to try to, oh, that's not it. AFL fuzz, yeah, there we go. So it's going to run on our program. I gave it an input file actually, which is just the input file is just this, ASTF. That's valid input to the program. The program expects 4 bytes data. Here's 4 bytes. I just put that as the input file. And so it'll use that to, I'm not really sure what it does. I didn't look into it too much, but it'll use that to figure out what it needs to do in order to input into this program. So if I run this, it's going to start. And the output's not going to be too interesting for this because this program is so simple, there's not much to do with it. But you can see right away it got 1 unique crash and 1 total path, which makes sense since there's not much this program can do. You only have 1 thing to do with it. We're actually at over 10,000 total crashes. It's just exploiting that same, well, not exploiting, it's making it crash that same way over and over again, just by probably providing too long of input. And if we were trying to find a bug in this, we'd have one. Not only does it show this, but we can go back and see what exactly caused that and what can be done to reproduce it. So it makes a nice output directory, which I have called Fuzzer, and that creates a bunch of nice stuff. There's plot data, there's all these statistics that we can dig into if we wanted to. But most notably is the crashes directory, so that's where it actually puts the information about the crash. So that first file there, the ID 00000 is that first crash. So reading this alone, I don't think it has anything interesting in it. But yeah, it's just some binary stuff. Or maybe that's the input string it probably put in. But there are other tools that will graphically and otherwise show you what you can do with this information, how to actually take it from just a crash into an actual way to exploit this vulnerability. So that's pretty much AFL. I didn't really spend much time on learning AFL, but it's definitely a big tool that's used for a lot of projects, and it's definitely a good way to try finding some of these bugs in an automated way, not by hand, which is still doable in some cases, but it'll take a lot longer. And there are already people out there that are running this on every inch of the Linux kernel and other stuff, so they'll probably beat you to it if you're doing it by hand. So anyway, where is my slideshow? That is all I had for today. There's some further reading you can do. There's some articles on fixing bugs in the Linux kernel or how trying to keep it secure. Also, the website for AFL is a good resource as well. So with that, are there any questions on this sort of thing in general or anything like that? Yes, Rocky.
Have you tried any bug bounty stuff?
I have not really done much bug bounty stuff. It's definitely a good thing to check out. A lot of those are, this sort of thing might not be as useful for because this is kind of targeted toward, I guess, applications you can run locally, binary stuff like that. I mean, it might work in some cases, but yeah, bug bounties are good to check out, I'd say. You can get money and other rewards out of it. Does that answer your question?
Yeah.
Okay.
My question was just if you've done it.
No, not really. I mean, I've looked at a little bit, but. Any more questions at all about anything related to vulnerabilities, exploits, etc.? Question? No? All right, if that's it, I'll hand it over back to Daniel, and we will do the next thing on the list. I will leave the candy canes up here if anyone would like one who didn't answer a question. All right. Okay. Thank you.
My name's Tyler Stapler. I'm senior here at Iowa State, and I participated on last year's National Cyber Analyst Challenge team. what the challenge is, you get together with a group of, I think it's four or five, and you get put in a room to solve like challenging problems. So say a company gets hacked, they want to find out who did it and kind of why, what steps they should take to mitigate that. That's kind of the goal of the challenge. So for the team skills that you're looking for, just being a generalist really helps. So if you're really, really technically deep in one area, just having an awareness of other things that are going on. So knowing, okay, on a Linux system, what types of files should exist in the web server? Like what things might be placed there maliciously? If you're really into Linux, also having an awareness of how Windows works and that, I guess, environment is set up. So I would say really anyone can contribute to the team. I would definitely recommend as you're preparing for this that you dig into digital forensics, incident response. One of the things that's good to keep in mind, during this competition, you'll be mentored by the companies who put it on. And so as a part of it, they'll say, hey, here are the tools that we recommend using. Definitely use those tools. So we ran into situations where you're not given a live machine to, for example, the scenario that we encountered, we were reinvestigating a case of this country's military systems were hacked, and Leidos was called in to figure out how that happened. They couldn't just give us the XP machine that was running in this military installation, but they could give us like memory dumps, I guess network traffic, as well as like FTK images. There are various tools that you can use to do these kinds of forensics, and so as you're thinking about this, keep that in mind. And know, like, when I participated in the competition, I didn't really have any deep experience in like digital forensics. I've since taken the class offered at Iowa State, but if you have interest to learn and you have like background in computing, as I'm sure a lot of you do, you have the possibility to contribute. So I guess any questions that might have been a bad explanation, go ahead.
You got a high-level overview? I haven't even done a preliminary Google search on this yet.
Yeah, so, okay. The first couple years of this competition were sponsored by like Lockheed Martin and then Leidos, which was part of Lockheed Martin that got spun off. They have a group that specifically is called in to do incident response. And this competition is supposed to simulate the types of things that you would do as a cyber analyst. And the competition's 3 stages. The first stage, you get sent gigabytes worth of files, and they tell you, okay, you have, I don't know, a month time span. Please figure out all you can from this data and then give your report to us. And so after that first stage, I think half of the teams in previous years, they're changing up the format of the competition, so all this might change. But after you do the initial round, if your team selected to go on, the second round consisted of a lot of training. So they had WebExes where they had professionals walk us through like what sorts of the things that they would do on an engagement, and yeah, kind of just taught you the tools of the trade. That, I guess that plays into what I mentioned earlier. Pay attention to what they tell you, because it's very specific. We thought like, oh yeah, we could do it, it's great. We're just gonna use Linux, forget all that Windows stuff. But then they gave us a laptop with a, like SATA 1 drive and FTK imager, and those were most of the files we got. So pay attention to that. And the final phase, we were flown out to Reston, Virginia to compete with, it was like the final group, 8 other teams. And they put you in a room for several hours with like a monitor / babysitter to make sure you don't do anything bad. But you get files, so I guess, like I mentioned, you get a hard drive that has this data on it, and it's your goal to figure out what happened. So you have like PCAPs from their IDS, like their network traffic, several images of the hosts on their network, as well as just other miscellaneous files that you can use to do forensics. And you need to reconstruct what happened. I think the main questions they wanted to answer, there were these two events. One, this website was hacked, and the other, they think some data was exfiltrated. They wanted to know, were these two incidents related, and what additional steps should this company take to like mitigate the threat? So does that somewhat give you insight into it? Anyone else?
Do you know when this is this year?
I'm not sure if they put out the dates yet. It'll be sometime in the spring. Yeah. Typically, there's a couple month span in between the phases. So I guess if time commitment would be helpful, I would say like expect to put in 2-3 hours a week in just like learning and doing meetings, and then like a couple days towards the end of when the competition would be. So, anyone else?
I just looked it up, but so, I don't know, John, are you gonna talk more?
I can.
Okay.
Yeah.
Well, I know that the registration ends December 15th, so in a few weeks. Basically, you have to get a team of 4 to 5 people and get a faculty advisor. So Iowa State, that's the team that you are
Yeah.
on. It's kind of, our having the information session is for the Iowa State team, but I don't think that means that you have to. I mean, I think there's other ways to form a team. But anyways, the registration ends in just a few weeks. Then the case, it looks like it would start in late January, early February, and kind of go all the way up through April 12th and 13th, I guess.
Okay.
Is the final presentation, but yeah.
Yeah, thanks for the clarification. Awesome. Anyone else?
Well, I guess just logistics-wise, are you trying to find members for your team, or?
So, since I participated in the past, I'm ineligible to participate again, but we're trying to find members for the Iowa State team. John, you want to?
Right, I'm one of 3 coaches for the Iowa State team. Jim Davis, Doug Jacobson, and myself are the coach. Now, this is the 3rd year that we participated. The first year, we won the national championship. The second year, we were a national finalist with Tyler's team. And so we've been successful at this. We do have a lot of experience. We actually had a team that was going to compete this spring, but the curveball they threw at us was that if you've competed before, you can't compete again.
Okay.
So we are looking to form a whole new team. And I think it's 1 team per school. I don't recall if this one's by invitation only, but it sounds like you can register for it. But we've been invited to participate again. Now, if you have an interest, and if you could talk a little bit about specific skills. I mean, you've mentioned some.
Yeah.
Any that you think that are really important?
So it's pretty good to have a diverse skill, so don't count yourself out if you don't know anything. But having a solid knowledge of like network forensics, so being really familiar with Wireshark comes in handy. That we carried ourselves through the competition on those skills. Using volatility for like memory forensics, as well as like FTK or NCASE. Those are both like disk imager, or yeah, they work with disk images, and you can search through the disk for files. But yeah, it depends on how they run the competition again, but having a knowledge of like file systems forensics, very important, as well as network forensics. And if you have application knowledge, so say if you build like web applications and you have knowledge of those, that comes in handy, knowing like what is this program, what does it do? That came in handy for us. Any I'm forgetting, John?
Well, that's part of it, our
Yeah.
technical skills. We're looking for because technical skills are important, presentation skills are important, because part of what you'll be doing is putting together an executive level presentation to present to the judges, which means that you're talking to grandma and grandpa and trying to convince them that you're right about what you found and what you're trying to do. So the presentation skills are important. Teamwork is extremely important. That was one of the reasons that we won the first year, was because the team was so well oiled that they were impressed with the way that they had worked together. So there's a variety of skills. Don't be afraid that I'm not real deep technically, because you may have other skills that come to the table. And we're looking for different majors. The team that won, we had some engineering students. We had a political science kid who was phenomenal. He was great. Jason, I love Jason. And a young lady who was from MIS, who actually did all the Wireshark and held her own against everyone else. For your team, I know that we had engineering. What were some of the other disciplines?
Engineering, information assurance, another poli-sci major, I think computer engineering, yep. Oh, so I would say if you have like technical knowledge of, say, like, I don't know, computer systems, like math in and of itself, no, but problem solving is definitely very important. Being able to put together the various, I don't know, pieces of the puzzle. And like John rightfully emphasized, you're judged mostly on your presentation. So the presentation you give at the end, anything you leave out of that, if it's unclear, it doesn't matter. So being able to really present your findings in a effective way is going to be pretty important. So if you have, like speaking skills and can speak professionally, that comes in handy.
And we can help coach you on that.
Yeah.
So you said that there were 3 different mentors, but there's one group, or you had multiple groups?
There's one group per school.
So the 3 mentors are all for the same,
Right.
and the group is 4 to 5 people, you said?
Yep, and I just looked that up to confirm. Each school can only have one team, so this is the Iowa State team. 4 to 5 students, can be undergraduate or master's, not PhD students. But other than that, that's pretty much up to the coaches, I think. You guys are going to decide kind of how to form the team, so.
Has anyone done case competitions before? I mean, this in a way is like a case comp, but a lot more analysis than you might normally do. Now, do you know does it mention what the prizes are? And I know that they're changing the
Yeah.
format, and so I'm not quite sure if it's as lucrative as it was in the prior year.
So the winning team will receive up to $20,000, a max of $4,000 per student. And the runner-up team will receive up to $5,000, a max of $1,000 per student.
When we won, each kid got $5,000.
Yeah. And if you get accepted into phase 2, you'll get training on cyber tactics, training materials, industry mentor. So you'll get a lot of that kind of information too before the actual competition. So if you feel like you don't know anything now, or you wouldn't be a good candidate, they're going to even provide information. They're going to pay for basically all the travel and stuff too. So it's not like you're going to have to put in any money to worry about hotels and lodging. That's all coming from the competition, and I think anything extra would probably be covered by Iowa State anyways. So no expense to you or anything like that. But it's a good opportunity for sure.
You get to learn about a pretty exciting field that you probably might not know exists. So I would definitely recommend it. I had a great time, and yeah, hopefully Iowa State does well again.
So if people are interested, John, should they,
If you have any interest, email Jim Davis by December 5th, which is 1 week from today. And we will be choosing the team the following week. In the email, please specify your level of interest and what skills that you're bringing to the table. Now, that doesn't mean that you feel like you're not as deep technically or your presentation skills aren't quite there, that doesn't mean that you'll be excluded from that. We're just looking to see how well-rounded potential team members are and what skill sets that there are out there that we can work with. And how much effort did you have to put in learning some of these tools on your own?
On my own, I spent, I don't know, probably a week before school started last summer or whenever it was, just learning about the tools, doing a lot of reading. A lot of the tools have fairly in-depth like manuals, but I don't think it was that challenging. So I had a base of, I knew what an operating system is. Like if you've taken an operating systems class, if you kind of know like what a file system is, you can pick up these tools. So I don't know, forensic examiners, you can do this as an occupation, go get training. I don't know if there's 2 years programs, but they make especially a lot of the tools that you end up using for the competition, like I don't know, FTK and NCase maybe, like those are used in industry because they have a lot of support behind them and you can pick them up. So I guess that's kind of a non-answer, but I spent like, I don't know, I want to say 100 hours in total teaching myself things that I probably was going to learn anyway, but front-loaded the effort and like learned specific things that were necessary for the competition. So like, oh, what's a Hive file do on Windows? Like, I don't know, look it up on Google. Oh, that's what it does. Cool, next problem. So it'll be a lot of that, especially if you, like no one knows all of this stuff and carries it around in their head for the most part, but you can get there.
How did you know what to start learning? You said you're like Googling all these things. How did you have any idea of what you should look into?
So once we got we had previous files from prior years, so we knew like, okay, there's going to be Wireshark, there's going to be volatility. Those are two pretty big tools in and of itself. Like if you went and learned about Wireshark, there's a ton of tutorials on YouTube. You could, I think I just like watched them while I was eating, and they kind of give you an awareness of like what is available. So it's really hard to learn things when you don't know what you don't know, but just getting an awareness of like, okay, what do you use this tool for? That's pretty helpful. So like Wireshark, volatility, like FTK. I would say those big three, like figure out what those tools are used for and what they do. And from there, if you need to do a specific thing with the tool, when the time comes, you should be able to just like look it up.
And we still have the data from the previous two competitions too.
Yeah, we do. And I think somewhere we have like a list of all the tools we used, but those are the big three, and yeah, knowing about those is going to be pretty helpful. So well, if there aren't any more questions, that's kind of all. Oh,
Sorry,
yes.
Jim Davis.
Yeah.
In the College of Business. Jim Davis.
All right, well, that's all I have.
Thank you very much.
Yeah, no problem. So, yeah, email Jim, and I guess if you have any more questions, you can email me to T Stapler. Yeah. So, cool.
Would you be willing to answer questions about some of the tools that you get?
Oh, totally, yeah. So I did a pretty bad job presenting all of the information, but if you have specific questions, I'm more than happy to answer them. So if there's anything you think of, like when you're walking home, like by all means, shoot me an email, and I'm sure John, Jim, and the mentors could just like put you in contact with me or other members of the previous team. Like if you need more like in-depth, like here, what do you think about this type questions? So, yep.
Awesome. All right. It's a great opportunity, and it really looks good on your resume.
Yeah.
Thanks.
Yeah.
So that pretty much wraps up the meeting. I will be sending out a survey, so if anybody who's part of IASG or wants to become part of it, you guys can fill that out if you're interested in seeing anything new next semester. Logan, do we have any updates on Slack? No, not at this moment. Okay. Well, we'll be working towards that. And yeah, so no more meetings for the rest of the semester. I will be emailing student into the next semester when we'll be meeting, but I don't think it's not usually right away. But we'll get that figured out and get that sent out